Hello everyone. Today we'll solve the problem find all duplicates in an array. We're given an array of length n with integers from 1 to n, and each of them appears once or twice, and we have to return those that appear twice. For it not to be too easy, we have to do it in linear time and constant extra space, presumably not counting the space required to return the result. Now this is quite similar to yesterday's problem, where we were asked to find the one element that appears more than once, perhaps more than twice. But there we weren't able to modify the array. And here we do not have that stipulation, and this is going to be very useful in coming up with a fast and easy solution. What we want to do is for each element that we visit, we look at the place that it's pointing to, and we somehow mark that place in a way that both doesn't irreversibly forget the value that is currently stored in that place, and also can be later recognized as a marking. If we do that, then wherever we visit the same cell a second time, we can recognize that we have visited it before and add it into the result array. There are many choices of what to consider, what to use as your reversible modification. Probably the simplest one to come up with is just to negate the number that's already there. But you can also do something like add the value n to each of those. Whatever allows us to recognize that an item has been touched and then to undo that touching. So, for instance, if we are given an array where, let's say, we have a 1, a 2, another 1, a 3, and another 2, and again we'll mark the indices as 0, 1, 2, 3, and 4. And now we're going to traverse through this array, calculate the index that it's pointing to, which in case of a positive number like this 1 is going to just be this number minus 1, in this case 0. If a number is negative, we have to first take the absolute value. So let's see this in action on our example. In the first step, we have a 1, which is pointing to itself, and we change it to a minus 1. Then we have a 2. 2 is also pointing to itself, so we change it into minus 2. Then we have another 1 pointing to the element of index 0. So we look at this element and we see that it is negative. So we add 1 to the result. Then we see a 3. 3 is pointing here, so we negate this value. And then we see a 2, which is pointing here. We see that the value here is negative, and so we write the absolute value of it into the result. And that's the result we have. Pay attention to the fact that the negation is here not for when we consider this number when we go through the array from the left. In that case, we have to always take the absolute value and consider it as if the number was positive, but for the second time that we visit the same position. So in this case, this one flips the sign of itself, and this one sees that it's negative. Same thing here. This 2 flips the sign of itself, and then this one sees that it's negative. And now for the code, it's really simple. We can simply go through all the numbers. This is the index that the number is currently pointing to. So if it's negative, we do not care about that. We just take the absolute value, and we have to subtract 1 since we're using 0 indexing. And now if at this position the number is negative, this is the second occurrence, and we can push it into the result. And if not, we have to flip it to be negative. And then we just return the result.